Sit down where you want. You are welcome wherever. Okay. Well, we're like really heavy on this side of the room over here. You want to tip the building? So, all right. So most of you guys, welcome back. Most of you guys have been here before. Welcome. Tell me how to pronounce your name one more time. Yurgo. Nice to meet you. I'm Jeff. I'm not. Can you guys go around the room and say all who you are? Start with you. Guys.
I'm Jack. Drew. I'm Jorgen.
Okay. There's not going to be a quiz, by the way.
I'm Gordon.
Okay.
I'm Will.
Cool. Yeah. Welcome back, and welcome for the first time. So usually I kind of start out kind of getting people oriented with, hey Chandling, welcome. Getting people oriented with sort of robotics and the approach that I like to take here. But I thought it might be fun to start out a little bit differently and do sort of a hands-on activity, just to kind of get you exposed to what we're working towards here, which is, welcome, Cody. You missed all the intros. Everybody else, Cody, everybody else. I think one of the best ways to do that would be to get hands-on with these tiny robots here. So you're fine where you are. We're going to do a couple of things here. How do you guys feel about dividing up into a couple of groups? We need somebody with a laptop on both sides.
I have a laptop.
Do you have a laptop? Can you move up here for a minute? Will your battery last for a few minutes? I realized that was going to be a challenge. How about you? How's your battery?
It's all right.
All right. So what we're going to do here, so some of you guys may have seen these before. This is a little robot design. Michael, my partner in this whole LoisLab venture, and I designed this. We had originally started with a larger robot, this thing over here. We were calling this the Q-bot. I don't remember exactly why. Oh, because we were using it for Q learning. That's why. And so this was fine and all. But one day he just sort of said, we should build a robot that can navigate a maze, like a little robot, like a mouse going through a maze. So I would say, version 2 got a bit smaller. Like, that was not bad, right? And so, if we talk about what we want to do in this class in the big picture, like we're designing, my desired output would be to equip you guys all with a set of skills that you can use to conceive of your own robots and build them, right? For whatever your pursuits are. But here at LoisLab, at least currently, is organize our lessons around artificial intelligence and machine learning. And so that sort of gives us a grounded place to kind of have conversations around robotic designs and what we want to do with them, right? So robots in the context of machine learning is building machines that can use AI algorithms to learn how to do tasks, okay? So before we go down the road of understanding what those tasks might be and how we're going to pursue them with our robot designs, I thought it might be fun to just kind of play with these a little bit first. So Team Jack, can I get a couple of people over there with him? And Team Gordon, can we get a couple of people over here? It doesn't need to be the whole class, but let's get a little, participation here. I've turned your robot on. Okay, why don't you flip the switch on that one? Okay, and what we're going to do is we're going to have a kind of not too competitive challenge here. This is also going to be helpful because you guys are going to get an idea on what it's going to be like interacting with these Raspberry Pis and the robots that you're going to build, because Raspberry Pi that powers these things is going to be the core of our designs here. Okay? Yeah, you guys know some of the same people. Somebody steal the rubber band off. Here it is. Okay. Somebody stole my tire. Jane, why don't you come over and join Team Gordon over here? Okay. So, Does anybody in the audience have any experience working with little Unix computers? That's okay. Don't need to.
Does it count for me because I already taken it?
Everything counts. Okay. I'm going to put my screen up on the monitor here so we can see what's going on. So basically, those robots are powering up, and we got to figure out where they are on the network so we can connect to them. Because those little robots on the Raspberry Pi that's running on them is work, and we're going to connect in so we can control the thing. You sure can. That's the whole idea here. Figuring that out right now. Okay. Yes, you can do that. Okay, Jack, you are. I'm going to give you an IP address. Have you ever done anything before?
Yeah, you just type it
Into the Google? Actually, we can use the we can use your web browser. Pop up a web browser and go to this address, 192.168.0.106, and then put a colon after it, and then type 8,000. It's the one with the 2 dots. Okay, and then and then Gordon, I want you to go to 192.168.0.116 colon 8,000. Yeah. Okay. Login is password, a username of LoisLab and a password of LoisLab. Okay. Okay. Sorry, I got their address wrong. Can you go to 104? Yeah. Do 104 instead.
Where's the boy?
Are you loading up Cloud9?
Yes.
Excellent.
Remember, you're running.
Okay. So we're going to learn more about the Raspberry Pis in a later class, probably next week. I'm asking a lot of this little tiny Raspberry Pi.
Username, password?
LoisLab. So the brain inside that robot is this thing right here. This is a Raspberry Pi Zero W. Okay. It's great. It's about the size of a stick of gum. Costs about $10. But I'm doing a lot of stuff on there right now. It's a web server. It's a code development environment. It's a wireless access point. You know, it's working real hard. So sometimes things may be a little slow. Okay?
Anyone got a solid object?
All right. Can you cast your screen up here?
Yes.
Okay.
Are there any like common
Are you getting into?
Cloud9.
Cool. Do you want to cast up here?
White doesn't exist on Android. Are there any like? Can I go left? Is that okay?
Well, why don't you go right so you're the screen that you can actually see? I disagree. It's somebody's already casting to it. What was that, Gordon?
Source not supported. Of course, it could be that the browser is at the moment trying to deal with connecting.
We can get by without casting if we need to, but
I've cast up there before, but right now it just says source not supported.
yep.
Oh, wait a minute. Things are happening. Yeah. Computer's old like me.
Now it's so I can go left. Yeah, but that's. Oh, he's going.
Well, it'd be really confusing if he went. You'd be like cross-screened.
I still. You went left. You went nowhere.
Okay, so we need to bring up a little program on this robot that's going to let us give it commands. Okay, so see this? The blue pane down in the bottom part is a terminal window. You can type commands in there. Okay, so do an ls, which is a file listing. I don't know how Unixy you are. I'm just going to walk you through it. What's that? Well, squiggly is like your home directory. Okay, so type cd space change directory. Capitalization matters. Okay, the program that we want to run is called Start WebBot. Here's how you do it. Type sudo, sudo, space, Python 3, space, and then that file is start_webbot.py. So if you type start and hit tab, it'll complete it for you. All right, and hit enter. Should give an error and then say something about listening on port E. Okay, bring up another tab. Yep. Now go to that same address, which was 192.168.0.106. I just want the IP this time, though, not the 8,000. Okay. So this is going to be, go ahead. Yep. Hit enter. This is a little program that Michael wrote that allows you to give commands to the robot. So play around with that for a minute while I get these guys up and running.
Action 1, 0.
Yeah, click on one of them.
Oh, we did something. I can tell you that.
What's that?
It turned the link purple.
Click on it again. Is this not spinning? Oh, you know what?
Ah, I see. Is there a certain internet?
Try again.
No, you're good, man.
Hit it again.
Is that one on? Oh, it's loading. And it's waiting. It's doing a thing.
Hit it one more time. There you go. All right. Play around with that for a minute. Don't totally kill the battery. Okay. So let's get command web interface thingy up and running. So in this little terminal window down here, okay, type ls so we can see where we are. Okay, so we've minibot, cd into minibot, so cd space. It's capitalization matters, so you got to do capital M. But then, yep, but you can do tab completion, so that's all right. Okay, now we're going to start up the little program that's going to allow us to control that. Okay, I'm just going to give you the command to get us up and running. So sudo sudo. Yep. Yep.
I was thinking sudo.
Hold on, I'm not done yet. Space. Python 3. Space. Start. Tab. There's more to it, but it's easier just to do tab completion. And now hit enter. Yep. So this is going to start up. Listening on port 80, so that's good. Okay. So pop another tab. Okay. And we're going to go to that same address again, which is 192, 168.0.104. Get rid of 1,000 though. We just want to go to.
We want the drag to be in the back. No, the pin. Oh, it's still going. Why is it?
Yep. Cool. All right. So try one of those actions. Okay. Cool. All right. So that took a minute. The more familiar we get with the Raspberry Pis and the interface, the easier that'll be. But so what we've got is we've got two little web bots that you can control through the web interface. Now there's 8 commands, 0 through 7, I think. Is that right? And if you play with that for a minute, you're going to see kind of what the different commands do. All right? So yeah, play with it for a minute and try to figure out kind of what does what. Okay? And then I'm going to give you guys a little challenge.
Reorder. I think it will give it something.
Can I borrow this piece of tape? Well, isn't it kind of relative? Yeah, it's really whatever you want it to be. Okay, so I'm going to set you guys each up with a little challenge here. Actually, yeah, that's fine. Okay, so this is your goal line. I don't know if that's forward or backward. No. You get to continue taking the class, I guess. Okay. Okay, so here's the deal, guys. Okay, I want you to try to use the little commands in the web interface, and I want you to see if you can push the little roll of tape that Jayden just moved. See if you can use just the interface to push the roll of tape to the other side of the line. All right? Give it a try. It's in service of a greater good. We'll get there. Don't worry about the why just yet. Feel free to work as a team here if you guys can be supporting each other. Don't run off the end of the table there.
Oh, that's the wrong. Click, do it again. Why is that one forward now?
It has not changed unless you hit.
No.
Oh, did you hit random?
I tried reset.
Okay.
Okay. Yes, but which one is it? I don't remember. I would say action 0 is probably this one. I think action 0 is this way.
Yes, it is.
Okay.
Yep.
Yeah, too far. Pseudo 2. Oh, yeah. For my purpose.
Absolutely, you should. Oh, we got some good progress over here.
Watch us win.
What? What? You were like nowhere, and then suddenly you're like, okay, done.
No, it's because we spent all this time getting over here. Perfectly lined up.
Okay. So, all right. So, guys, I have a slightly different challenge for you now. Okay. Are you gonna? Oh! Come on, one more. All right. Okay. So, guys, I have a slightly different challenge for you now. Okay. So, if we set this up again.
Jack has to go in the other room.
Yeah. Jack has to do it from the other room. No. But do you guys want to maybe switch keyboard operators?
Can you click the buttons? That'd be cool if they were. No.
Okay, so this time, let's see, Gordon, is this your computer up here? Okay, I want you guys to click on the randomize button. So this randomize is the second option up from the bottom. Now, so what the randomize button does is those 8 actions, 0 through 7, are now scrambled, okay? And yeah, so something else may have happened. It generated a random set of instructions somewhere between 4 and 10, right? So you've got different instructions. They do different things. There may be a different number of them, and they may not make any sense. Like before, I don't know if you guys noticed, but they were like a left, right, forward, and back, and then a left, right, forward, and back that were like faster or longer in duration. There's no guarantee that you're going to have those. So after you click randomize, give it a try again and see if you can. Well, that's the point, is you don't know. So go ahead and click through them and see if you can figure out a combination of instructions that you can use.
None of them go forward.
Okay, what does 2 do? Okay, so one is forward, 2 is back. 3 is, it's more. That's a lot. Oh, wait, we can get there.
Wow, that's an aggressive rotation.
One. Oh, wait. No. Okay, wait. You need to get on the other side. What does 4 do? Yeah, let's find out. Yeah, find out what the other ones do. It's all right. Okay, what? Okay, so
You guys will get there. It's a random selection of moves, so that can absolutely happen.
Oh yeah! We have like 6 left. We have, I think, 3 forwards and 3 back.
Nice.
Okay, back up.
If you've got at least 1 forward, 1 back, and 1 left turn, actually, if you have a forward and a left turn, you theoretically should be able to. Yeah.
Did you go forward?
That's okay. Keep going.
9 was a little. Oh, we're close forward.
Yep.
Catch, did I?
You just have to. All you need
Did I kill it? I might have killed it in my catch. I might have powered it off.
Oh, that's okay. Turn it back on. You're going to have to restart it. But so that might actually be a good point. I mean, are you guys okay pausing here for discussion, or do you want to keep bashing on the thing? Okay. So yeah, well, that's because we have to restart it. That's okay. Don't worry about it. Okay, so guys, so let's talk about this for a minute. So we've got this robot, and it listens and accepts commands, right? We built that little web page so you could click on the links to move it around for convenience. Actually, pointing your web browser at the robot and doing something like action equals 0 through 7 or whatever, and it'll actually do those same things. So you can fire requests at the robot, and it does things, okay? going to the URL bar, do like 192.168.0.104/action equals 0, and it'll do whatever action. So, guys, you could use this robot to do a task, right? Like push a roll of masking tape around a table or navigate a maze or whatever, but you need to know a few things, right? For those of you that were around last night for Michael's class, Machine Learning with Python, some of this might start to sound familiar about using machine learning to solve problems or do tasks where you don't necessarily need to know the rules, right? You can learn how to do a task through trial and error if you have an algorithm that is sufficient for that. So let's take a look at a slightly different example, which uses these robots sort of in a similar way. What was the address of this robot? That's really cool, by the way. It's in your URL bar. It's 106? OK, so can I get everybody to move over here now? And I'm going to drive for a minute. But I want you guys to be able to see the screen. So, you can sit in stools or chairs or stand or whatever. I'm going to throw this up on the screen. And we're going to look at a slightly different way to use the robots. All right, so let's do desktop, screen left. OK, so see this thing behind me here? It's a camera on the end of a broomstick, which might seem a little strange. I mean, I don't know. If you've hung out here for a while, maybe that's not that strange at all. So let's take a look at this little bit of code here. Michael and I put this environment together. OK, so has anybody here heard of a library called OpenCV? Yes, yes, yes. OK. OpenCV was written by some really people. And it's basically a computer vision library or a computer vision system. So if you're building a robot or you're running a computer program and you need to track objects or see how big something is or track motion around or something like that, OpenCV is very commonly used for that kind of thing because it's a pretty well-developed library and it's relatively easy. Here is live video. We've got some processed video, which doesn't look like it's calibrated very well because you can't really see too much, and we'll fix that in a minute. And then over there is just the black and white video. So what this thing can do with the web camera and is it can track the colored objects that are down on the floor here. So on the floor here, I've got an orange Post-it pad, okay? And I've got a couple of Post-it notes stuck to the top of the robot that you guys were using over there. I don't know if you saw the colored squares on top. So those are 3 different colors, okay? And so if we use something like OpenCV, let me see if my calibration is good enough to do what we need to do here if I need to walk through the calibration here. Waiting. OK, so that's the yellow image, that's the orange image, and that's the pink image. That looks pretty good. OK, so if you've got 2 different colors sitting on the robot and open where the robot is in the play field, and also what direction it's facing, right? Because if you know you got this end of the robot and that color on the other end of the robot, and you can figure out the orientation of them relative to each other, you can figure out a heading, right? I'm pointed this way, or I'm pointed that way, or whatever. Does that make sense? OK? And then we've got a target that's a different color down there. Okay. So it looks like the colors are working well enough. I'm not going to go into a deep dive on OpenCV right now, but just understand that it's not too difficult to set it up to track those different colors and use them as objects in our algorithms. OK? So let's take a look at an example that Michael put together that's going to, the robot is going to seek out the target, which is the orange Post-it pad. Okay? Now, similar to the discussion that some of you guys were around for last night, the robot is not programmed to find that target. Okay? The robot doesn't really know how to do anything except commands and wander around. Okay? But the computer over here is going to be running an algorithm that's going to try a whole bunch of things. It's going to do a bunch of trial and error. And it's going to get feedback on whether the things it tried helped the situation, hurt the situation, or were sort of indifferent, right? And over time, through trial and error, this thing is going to learn how to find that target. So let's take a look at what that looks like.
Is your robot getting the data from the camera through the connection?
No. Let's come back to that subject and that question in just a second. Let me get this running, and then we'll talk a little bit more. So, all right, so let's do. Okay, do you guys remember what that IP was again? It was 192.168.0.106, and we'll do minus speed 1. See if that works. All right. Our little robot is trying a bunch of things. Okay, so we'll let that run for a minute. Feel free to keep an eye on it. But I'm just going to distract you guys and talk a little bit more while it's going. A couple of things can happen that would go wrong here. There is a limit to the play field. So if the robot wanders out of the view of the camera, it's going to freak out, and then we'll have to restart it. Well, that's OK. All right. Oh, hey, look, it found the target. Right. OK, so not like super exciting and impressive, right? Because it only took like 8 tries for it to figure it out. But if you understand kind of what's going on under the hood, it's a pretty powerful idea. The robot doesn't know how to find the target. The robot learned through trial and error how to find the target. And if you abstract that to a whole other series of problems, so what are the ones that Michael was talking about last night? Playing tic-tac-toe and navigating a maze, right? So imagine if you were to write an environment for this robot where using something like OpenCV to see a maze, didn't know anything about mazes, but through trial and error figured out how to solve the maze, right? From there, it's a step up to what? Anybody know the creepy robot dogs that Boston Dynamics builds? Yeah? Yeah. Like, it's these sorts of things, or self-driving cars, like that kind of thing. These are the things that exist at the intersection between machine learning and robotics, right? That's these little robots that we build, and what you could theoretically take the skills forward and build after this, because the problems get more complex. You know, mathematically, they get harder to solve. You need more processing power, and the systems that you build to be physical manifestations of these problems get more complicated. But the concepts are the same. Right? You can build algorithms that through trial and error learn behaviors, and then over time they can learn how to do really complicated things. So Rubik's Cubes, navigate mazes, play games, you know, open doors, help people across the street, become our robot overlords, you know, like all of this stuff. So do you guys kind of get an idea of the direction that we're going here, right? If machine learning is the software side of this, and we can build software solutions to complicated problems, the robots that we build can connect with those algorithms and do complicated things in the physical world. Good? Make sense? Cool. We can play more with this later if you guys are interested. It's actually fun to fire it up and just see how long it takes, because each time it's creating a new instance of the learning algorithm, and sometimes it takes like 10 minutes to figure it out, and sometimes it takes like 4 moves. And you know, it's as we get further along, you'll kind of understand why. Okay, cool. All right, so why don't you guys sit back down? Question? Yeah.
Would it be practical to have it like remember its solutions and see like have it learn over multiple scenarios?
Yes.
Or is that more like,
Or like run them without actually.
is that more reinforcement?
Well, all we're going to be doing in either class at LoisLab is going to be some form of reinforcement learning. Reinforcement learning is the idea that you learn through experience over time through trial and error, right? So it's this whole category or this whole subsection of artificial intelligence. The idea that you're talking about, like in a simplistic example, you can throw away what you learned, and then who's running it? That's fine. Oh. Well, whatever. Doesn't really matter. But so, okay, seriously though, it is a little distracting. I see you looking innocent over there. Anyway, so to answer your question, the problem that we were solving over there is really simplistic, right? It's really just about, it's all right, I'll switch in a minute. Is a simple enough example that it can learn in a single sort of session in really only like a handful of moves. Like sometimes it takes longer. If we made the play field longer, obviously it would take significantly more time. Like if the camera was on the ceiling and the target was over there and the robot was over there, it would take a little while for it to figure out the set of actions or moves it should make in a given state for it to wander all the way over there. But the problem is fundamentally the same. The difference in what you're talking about is like once it populates the sort of data structure that stores all the stuff that it learned about how to find the target, when we run it again, it throws it away and starts again. But you could easily write a program that saves it somehow, right? So you could generate a set of values, and when you finish the thing, you could save that, like out to a file, for example, and then use it. Like you haven't gotten to this topic in the other class yet, but when you go through a learning exercise, you're exploring a space and you're generating data about how to move around in the environment. Later on, you take that data and you exploit the data. So it's exploration in the beginning and exploitation afterwards. And if you save the values that come out of your exploration, then you can exploit it repeatedly in the future. So that was a really good question. So, okay, let's take a step back. We sort of jumped right into the hands-on exercise. That was great, but let's just talk for a minute about kind of where we are in the world and what we're doing here. So, most of you have been here at LoisLab before. Welcome. I'm glad you guys are all back, and for those of you that have not been here before, I'm glad you're here joining us. Let me just bring up a slide deck real quick. And no, that's not me. Can I switch users, please? How does the internet work? There we go. Nobody look at my password.
Pretty sure it's ...
That's the combination of my luggage. No, that's totally not. Okay. So we did our little hands-on exercise. So, so this is a place, where we're trying to teach these subjects because, we think they're important and we think they're engaging and fun and all of that. And I'm glad you guys are here participating. But in particular, we're focused on robotics, right? And how to design and how to build robots. Does anybody have any previous experience building robots of any kind, assembling robots or creating your own or whatever? I see. Wow, that's kind of awesome. That's like everybody. So, okay, good on y'all. What kind of stuff have you done before? You said you were on a robotics team,
Yeah.
right? Cool.
So we do. I technically shouldn't be doing high school, but I do the high school robotics tournaments.
Hey, man, if they let you in, like.
Yeah. I can't drive the robot, which sucks, but.
Okay, cool. What about you guys? What have you done previously?
Well,
Or what are you doing now?
we're making this high school robotics team a thing.
Cool.
Yeah.
Good job.
Trying to restart that.
So there, so there used to be one, but then it just sort of fizzled?
The school stopped doing it.
Okay.
School decided they wanted jerseys for the cross-country team.
Okay. And so that meant no more robotics?
Yeah.
Okay, that's a little weird.
I think we've all done some other thing. We all did Lego, most of us.
Okay.
I've done like the small like hobby projects.
Cool. All right. Cody?
I'm part of a first robotics team at my school,
Cool.
and I just kind of came here because I wanted to understand most of the stuff that you're talking about there. So,
Awesome. Cool.
I'm at Trip Academy in Kittery, Maine.
Yep. Other side of the river. And you guys are Oyster River?
Yep.
And where are you? Newmarket. Cool. Jaden? Cool. And what have you done previously with robots, if you don't mind? Okay, that's cool. No previous experience required. Gordon?
I teach computer science at Portsmouth.
So, we're talking about robotics in service of like exploring AI, but that's not like, that doesn't have to be the focus or the only focus. My hope is that the skills are going to translate to other projects, right? Like before we kind of, LoisLab got into artificial intelligence and reinforcement learning, I was, building other robots and machines, for my own experiments or my own hobbies and, things like that. And so hopefully the skills translate and will allow you to, explore, your own sort of interesting things. There happen to be a couple of sort of bonkers examples in the room over there, because a student that I've been mentoring brought some stuff in to kind of video and document. But like there's a kayak sitting on a couple of chairs in there. Like by most definitions, that's a robot. You know, that's a kayak with a propulsion motor and an Arduino and a GPS unit, and you give it coordinates and it goes to the target. And what's that? It was a Berwick project, yes. You know, so machine learning is not the only thing, obviously, that you can use these things for, but you know, I find it to be a pretty exciting topic. So again, just sort of toward the goal of getting you guys oriented in the world, this is how I explain, I hope you guys can see that over there. This is sort of how I explain the pursuit of robotics, you know, when I'm talking to people about it. I see it as the intersection of three disciplines, right? Of the thing. 3D modeling and 3D printing is sort of my medium of choice here because it's I have here in the lab, but it's certainly not the only option. When we taught this class this past spring, we started out in realm, but I encourage students to sort of depart from way as soon as possible. As soon as you guys have an idea that you want to pursue and you feel confident in doing that, don't like stick to what I'm visualizing and putting in front of you. You know, go off and pursue that. One of the students that we had, Doug, he prototyped a mechanism with this modular frame that you're going to see in a few minutes, and he ripped the wheels off of that and parts. And he made a robot. So have anybody heard? Theo Jansen, and they're these that walk along, and they have somebody who had modeled the movement of those. Then he placed the parts that he 3D modeled and printed. So I personally would probably not have jumped into making a walking robot because kind of really complicated, you know, things that come along with making a robot walk, but fearlessly jumped into it, right? So you can really take these things in whatever direction that you want. Yes, I have video of it. We can look at that later. So anyway, mechanics, you know, things that I've gotten in front of this. A lot of people play with Lego when they were kids, or you know, whatever. So then there's another area, which is electronics. Right? So you guys have already seen the Raspberry Pi sort of in action here, but there's this to make the robot move, right? Or talk to, right? So the robot has some sort of way to interact or understand what's going on in the environment around it. You know, delivering power to those things. This isn't going to turn into an electrical engineering course, but my hope is that we're going to explore some of these things. Figure out how to use that sensor that you're interested in using. Or I don't want to use these little stepper motors anymore. I want to use an RC motor and make the thing go real fast. Or I want to use servos because you know, whatever you want to do, you know, have the tools to pursue those things. And then the third area, and I know some of you guys have some experience with that, and some of you guys are taking a class in that on Tuesday nights. We're going to be dabbling in that a little bit because coding is the instructions that are going to tell the thing to do the thing. You know, it's like how do the motors move? What do we do with the sensor data? How do we control it? How do we make it learn? You know, all of that stuff. The code is sort of the glue that makes it all work together. So one of the reasons that I like robotics so much is it doesn't really matter what your entry point is. It doesn't really matter which of these is passionate for you. You know, that can be your comfort zone. That can be where you live, at least initially. But all of these other things that you can into. Or maybe you're the kind of person who likes to kind of give themselves a challenge. You want to step out of the comfort zone and you want to focus on what you've never done before. Hopefully this topic will kind of let you do that. All right? Just a little bit about the environment here. Everybody knows that we have a Discord server. I know everybody, especially students here, you guys have super busy schedules, right? And so it's totally understandable. I'm not going to be giving you guys homework. It's understandable if you don't have a lot of time during the week to work on these things, but I'm hoping that you're going to be interested enough that you're going to be thinking about it. You know, if you're trying to figure out what your own personal robot design is going to be, hopefully, you know, you'll have a few minutes during the week to think about what that is. And the Discord server is the place where you can interact with each other and bounce ideas out, ask questions, show what you're working on. And the more you as a group use that as a tool, I find be able to provide to your classmates. So I really recommend doing that. The other thing is, please don't be afraid to you know, ask questions that, you know, maybe you think are really smart or maybe you think they're silly. It doesn't matter. Stretch a little bit. You know, move outside of your comfort zone. Try things. Like if you're not messing up from time to time, wiring something wrong, writing code doesn't work. Hopefully not cooking a Raspberry Pi because that gets kind of expensive. But if you're not occasionally doing something that pushing the boundaries, and so don't be embarrassed. And you know, we're all going to work together. We're all going to share our screens, and you know, and work on problems together. So just you know, try to understand that's the environment that we're working with in this pursuit. Does that make sense? All good? Okay. So I actually can't remember what I put in my slide. All right. So it is. We're about 45 minutes in. That's about halfway. Are you guys doing okay? Do you need a break? You need water? You know, all right. Well, we'll keep going for the moment. What I'd like to do next is talk a little bit about a different robot design. I want to talk about this one. Actually, I don't want to talk about it. I kind of want you guys to get hands-on with it. So this platform is something that I designed for this class. It's pretty derivative. You guys may have seen robots that look a lot like this. There's a lot of 3D printed designs out there. But I like this because I designed it to be modular, right? It gives us a convenient way to mount parts, but you can hang whatever you want off of it, right? It's got enough holes and parts that can be replaced and customized and all of that, that you could build this thing to be a Mars rover where you go explore, you know, what's going on the first floor when you're sitting on the second floor. Or you can put a sensor on it, and there's like this little mount right here is specific to a little Pi camera. Yeah, that's a different problem, but that would be a great robot for you to build. Is you know one that climbs or goes downstairs. This particular build of it has a laser sensor on the front because when we built this was doing a similar task to what we did over there. But this robot, you'd set it on the floor and you put a cardboard box over there, and through trial and error, it would locate the nearest physical object it could see. Similar idea to there. But you know, the robot just started out as the base platform that you could drive around, and then we built the camera mount, and then we built the sensor mount, and all of that. So you can expand this any way you want. So this is a good place to kind of start the robotics. You do it. I don't want you guys held back by, you know, what I, you know, conceived of as a robot on some given Tuesday. You know, and put that together in Fusion so that I could build a robot around it. So I have bins of parts, and 3, 6, yeah, we got enough. Let's all have some bins of parts. Have parts. Have parts. Yeah. I know, I could have done a better job with that. Here you go, sir.
I have a bin.
Sure.
Will
Yep. It's up to you. Whatever. You know.
Bro, that's more
Yeah.
material.
Do you want to play with the set too? Cool. All right. So if we need, I guess actually we will need some motors today. But what I'd like you to do is basically put it together, right? Lego it together. We've got. You guys are going to have to share a couple of things. In this drawer here, I've got some screw assortments and a couple of sets of Allen wrenches. Over here, thank you, Will. Yep, top drawer. There's another couple of screw assortments and another couple of Allen wrenches. If you guys can share, you actually don't really need the Allen wrenches until you want to snug everything up at the end. So you can kind of do it all by hand, but pull the screw assortments out and just take them back to your desks. You can use the one up here as a model, but honestly, you can probably figure it out. And if I can give you guys just a little bit of a mental prompt. As you're putting it together and you see kind of how it all goes together, it's pretty straightforward, but think about what you would do differently. I want you guys to be thinking about what you might want a robot to do and what you might want it to be able to know, okay? So think about how you might want it to move and all the different ways that a robot can move, right? Wheels are an obvious choice. I decided to use a pair of wheels and kind of like a skid so that it can, drive itself around. But maybe you want to use 4 wheels or 6 wheels. Maybe you want to use legs. Maybe you want to use 2 wheels. That's an interesting idea. Actually, maybe you want to use 1 wheel. Could you do 1 wheel? Yeah, you could do 1 wheel. Gordon, you should build a pirate robot. All right, I'm going to stop talking for a minute because my throat's getting sore. I'll be back in a second. Pirate robot. Cool. Nice. That's awesome. So have you got it? Doing something with the maze?
It's honestly called the thing you got. Just starts chugging away.
Cool.
Just starts chugging away through the maze. It's very overkill, but
Could you modify it so he's got a method that actually shows the status of the maze? You should be able to put something in there that, like, maybe every 100 iterations, it spits out the status of the maze.
Familiar with I worked at a rental store.
I want to make it
Connected machine.
learning how to fly is
probably is just blasting through one random. I don't know.
not redesign it then. It's not an issue of redesign. No, it works perfectly fine. It's hard to fly. It's not flying a plane. Yeah, but it's different.
Somehow make it work, but I don't really feel like doing that right now.
You don't have to do it just because I think it's a good idea. But you should post something to Discord and let Michael know how you're doing, because, I mean, he seemed pretty interested, and I bet he would love to hear about it. So keep him posted. He's interested.
Yes, I have.
Nope. Imagine what you could do with a machine learning algorithm in Python.
Yeah, I think, what was the name of the company that made the Terminator?
Skynet?
Skynet? Something dying.
Oh, Cyberdyne Systems.
Cyberdyne Systems, yes. So just don't make a Cyberdyne Systems thing. What's that? It became Arnold Schwarzenegger.
The little now robot is too cute for that, I think.
Yeah, I've seen pictures.
Do they still make them? Like, is he a...
Yeah, they
Current-
just came out with a new version, and that's apparently all they're focusing on. They refuse to help go with older models.
Oh, that's a bummer. Because, like, I mean, that was not an inexpensive... see it move is really impressive. That's all right. That's a wonderful thing about bolts. They're easy to change.
Okay, it's called the Parliament. Okay, boomer.
Okay, boomer.
Oh, it already started.
Do you have
Do I have a what?
things to hold the topping?
Do I have a thing to hold the
A little
or maybe, well, it probably work. You mean to hold the nut?
Yes.
You probably want a little pair of pliers. Work. Sure. Guys, if you're trying to tighten the bolts with the nut on the other side and you're not able to get enough grip on it with your fingers, there's needle nose pliers in the bottom drawers of each tool cabinet. Also, feel free to look in the tool cabinets and just understand what's there, because you guys, will be using the stuff as we're working on our robots. It's a couple of motors.
The mother of all batteries.
Do we need 3 motors or 2 motors?
For now.
Yeah, 2 for now. The third one on that design up there was specifically for the sensor, and that's totally optional. So you'll figure out what you want to do with the robot before
When you mount the
we
motor.
determine. You're going to need those also.
Ooh, are these axles? Oh, servos.
They are.
Sick.
How bad? So the servos are the rocket motors, right?
Yes.
It only goes 1 inch in one direction and 1 inch in the other direction.
2 inches of motion.
I have like old motor controllers that I haven't used in forever. What did you watch that? Be fine if I was like.
Oh yeah, yeah. Do whatever. The parts that we're using here are easy to use and straightforward. But if you've got something else you want to incorporate, absolutely do your thing. And or actually, I mean, you can probably figure out how to implement it. But if you need help, post a picture or a part number. Did I already give you those? Yeah.
I think it's like the most generic, like.
Did I give you 3?
5 volt,
Yes, I did.
12 volt, like motor controller on like Spark or whatever.
Okay.
You guys ever heard of this YouTuber called FunkyFresh.exe?
Shut up.
So you have 2 little boards. You have 2 little boards. You've got 2. Did I give you 2?
I have 2, yeah.
Okay, cool.
I rewatched your
I seem to have a spare for some reason. That's weird. Whatever. Jason, here's a couple of motors for you. Motors and boards.
Those are the forbidden words.
Couple of motors, a couple of little stepper boards.
No one cares.
So how are things at Beswick?
Doing okay.
Yeah?
Doing okay.
Yeah, I feel like we talked about it once, but I still don't know exactly what you guys do. Something like miniature pneumatics or hydraulics or something.
Yeah, it's just a cover for it. Or like illegal activity.
Yeah, money laundering.
Yeah, a little like Russian regulators. And
And so do you design parts, or are you more like a company that would design systems for somebody that needs something implemented, or?
no, it's product focused, product focused.
Okay,
But we do a lot of custom products for people. So
neat.
yeah.
Do you guys have your own manufacturing, or do you work with somebody who actually
We
manufactures?
outsource most of our manufacturing, but we have in-house prototyping capabilities and machine shop.
That must be really neat.
Yeah.
Yeah.
No, it takes some time sometimes because it's not like right now we only have one machinist and we're looking for some guys.
Okay, cool.
And we're also looking for more QC people with that. So.
Neat. Well, if this doesn't pan out, maybe we'll come work for you.
Yeah, you're almost like an engineer anyways.
Yeah, almost. I don't have an engineering background, but you know, it's enjoyable. No, the bill paying job is I work for a software company, so that for the moment is working out okay. But I do think it's really cool that you guys are located so nearby. You know, like you're like really a local company that is doing engineering and some manufacturing in the area. That's super cool. Do you guys take interns? Like, do you maybe partner with UNH or anything like that?
Not regularly. We did just hire someone that I met on the robotics team when I was.
Yeah, that's cool.
So we got one hire from that recently. He's doing really well.
Nice.
The cool thing is that kind of sometimes they're doing like more, I guess like coding and field work regarding like testing and stuff like that.
Okay, like automation of.
Not so interesting. It's more like the reason like LabVIEW.
Okay,
I don't know if you heard of that.
I've heard of it. I don't have any experience with it, but.
Yeah, it's kind of dry. It's not really like a very fun program. But it is like a lot of like programming in a sense, like a lot of logic that you have to, and there's a lot of like hoops you have to know how to get through.
Yep.
But essentially, just the point is to just like manipulate the data that you're getting from your products. So like if we have any flow curves or any pressure curves, then we can export that to a CSV cell, and we can kind of choose how we want to sample the data and all that. So LabVIEW allows you to kind of control all that.
Okay.
It's by natural instruments.
Cool.
So we've been doing well.
Nice.
Then we've been doing some more visual basic and stuff.
Yep.
Like little things, like if UPS or FedEx updates its shipping rates or something, we'll know right away. Or when we scan a barcode, it will show up to real-time data and stuff like that. So.
Yep. So you have developers in house that do stuff
Well,
for
our
you?
engineers, like I said, he's an ME, but he learned coding because he was part of the UNH robotics team.
Right.
They were short on people to code.
Yep.
And now he's kind of putting it to use.
That's super cool.
Of course, he knows like all relays and types of motors because, like, robotics team was like super strong on ECUs.
That's like the best success story for like somebody coming up through a robotics team and then going on to engineering school. That's like
It was a hobby.
yeah,
So that's the cool thing. It's like this was my hobby. And
right.
I did the thing that I like to do.
Yeah. Everybody should be so lucky, right?
That's so I tell students.
Yeah, but sometimes it's like the UNH robotics. Sometimes it's like, oh, this person was supposed to show up these last few sessions and they didn't show up.
Yeah.
And now competitions in 2 weeks.
Yeah.
You have to learn this. Right?
Yeah, right.
Right.
Trial by fire.
It's just how life is sometimes.
How's everybody doing? Anybody stuck on anything? Or are all your Lego skills translating forward? Your
Are we supposed to copy your designing?
There was a part of me that
No?
was like,
I mean, feel free to be creative.
But it doesn't fit. There's not a they don't line up well.
Let me see. It's possible. So here's the thing. So the stepper motors and the driver boards you're using, like this is a super common generic type. It's a 28 BYJ. And they were originally made for like HVAC systems, like opening and closing vents or something. But they're super cheap. Like a 5-pack of those things cost like $12 on Amazon or whatever. So they're great for these sorts of projects. But there's no guarantee that the next batch of 100,000 of the little boards that they make are exactly the same size as they used to be. So, if somebody changes the size of the board, I drill another hole. Like, You know, it's not a big deal. So, but so Jack, you figured out that if you rotate it 90 degrees, it lines up okay? Okay, cool. What's that?
So what other sensors do we have besides like?
I pull out a selection for us to kind of look through and talk about, but the stuff that I happen to have on hand right now are I've got some like accelerometer, gyro sensor kind of things, so you can sense um, orientation, but also movement, depending on if it's an accelerometer or gyro. They're slightly different but similar. I've got some ultrasonic distance sensors, so you can use that to.
Yeah, probably.
Yep. I think I've got some light sensors. I've got a pressure sensor, so you can detect like altitude changes. Let's see. I probably got a GPS module. But you know, depending on what you want to do, or you know what you have in mind, if there's something that we don't have, we can probably scavenge something. Or you know, I mean, a lot of these sensors these days, you know, it's like a couple of dollars for a sensor. So within reason, we can get stuff as well. Are you starting to have some thoughts on what you might want to do?
I have different ideas. I mean, the robotics team from Newmarket, we kind of hope to start building some stuff, kind of besides the robot.
Yeah,
So
I'm 100% in support of that.
yeah, like we'd like to build a like a control board because currently we're running 2 controllers,
Okay.
and it'd be nicer to have like a board to switch on different like things of the robot. So
Sure.
if you want something that's not like exactly isn't best fitted to like a trigger.
Okay.
So like we had on our bumpers to open and close the claw.
Yep.
So it'd be a lot better to have a button.
Yep. Gotcha. So in that case, would you be switching out the mapping of control, or would you be adding control to like adding an additional button or something like that to the controller to give you additional functionality?
I don't know. I think the route we would go is have it kind of appear as a controller. So like to a computer when you plug it into a USB, it would appear as a computer, but there'd be like I don't know some little controller or Raspberry Pi, like actually taking all of the input signals
Right.
and telling you what to do.
That should be doable. Yeah. The what do you? Yeah.
I don't know why I didn't do this before. But I tried with like that was from like thing that was like the style of that kind of better was like supposed to be like stripped back and but look cool too. And that one in particular was less like that. So this one similar, but it comes with
like a match set or like a cool. They should only go in one way. You guys doing all right?
Yeah. These boys here will not stop saying the word boomer.
You're part of the problem, Jack.
I am not as much as other people.
I don't know. It sounds like you're abdicating responsibility. But
Okay,
I think
That's like a boomer thing to do to shift lane like that.
nice.
Yeah.
Wheels.
Wheels.
How you doing?
Doing good.
Yeah?
I found I'm unzipping it now, but they had, so of course over the summer I was trying to get OpenCV on there.
Sure.
And then I just like recently at the end of the summer I found this article talking about OpenCV. And they had a link to Raspbian OS image with OpenCV.
Oh, wow. Okay, super interesting. So you're downloading that now?
Yeah.
Cool. What are you currently using for a Pi? Are you using the 0 from the class? Or because you had another one as well, right?
It's the one from the class, but it's been put all over the place, so it doesn't really matter how many people it is.
When you were talking about it on the Discord, didn't you have another one as well? Like maybe is that more powerful than this one, or is it like this?
Pretty much the same.
Oh, okay, I got you.
Yeah, I think, I don't know what happened, but the original OpenCV that I tried to download on it, every time I would try to download, it would always end up having like a memory issue with the Raspberry Pi.
Yeah.
I could never figure out like what was actually taking up all the memory, and I would reflash it every time and restart, and it got to the point where I was just sitting there watching it download, and I would just go around my day, and there was time where it took an entire, I think it was 6 days to download.
Wow.
OpenCV. I'm like, this is not right.
Yeah, well, yeah, so that's really slow for a download, but then also, like, compiling on that Pi takes a long time just because it's not a super powerful processor. What Michael found, because when we were building this system here, to start doing stuff with OpenCV, he actually installed OpenCV on his workstation using the pip installer. I don't know if you've used pip. It's a Python package that basically does management of Python libraries within the Python environment. And what it does, if it can, is it goes and finds pre-compiled binaries that are the right ones for your operating system, if it can. And so when we used pip3 to install OpenCV on this workstation over here, it took like minutes. Like it downloaded the pre-compiled binaries and put them in the right places, and it was done, and it just worked. Yeah, right. This will probably work because it's already built for you, but if it doesn't, you could try the pip option, and it should help out.
Because I've had to flash so many image files onto you.
Yeah.
I know the image files.
Well, you must be really good at it by now. Cool.
But yeah.
All right, we'll keep at it. OpenCV, I hadn't had really any experience with OpenCV before we started working on this, but it's powerful and straightforward. Like it's a really well written system. So. Are you talking about kids these days? I learned about the internet when I first started at UNH. When I was at UNH, it was the early days.
When I was at UNH, they had,
Yeah. But also we had the computer centers on campus, which were wired in. Yeah.
so when I first got there, it was an intro computer, it was Pascal, it was on chalkboard.
Wow,
And then there's a lab,
that's hardcore.
there's in another classroom with a chalkboard. Like there are a computer, and it was a client-server setup.
Yep.
And they're like, you gotta just go find the computer lab and figure out how to log in. They actually never took you to the computer.
Oh my gosh.
So I failed. And so then my senior year, and that was my senior year, I'm like, I gotta retake this to fix my GPA. By then it's a Mac lab.
Oh wow.
And I was like, it was like, I was right on that cusp, and it was amazing, and it was like, I'm sitting in the computer, I'm writing programs, I'm like, where was this class at all this major at this point? Yeah, but I was like, I would have stayed, I would have done computer science had that been the first class.
Yeah. So talk about early days of the internet. Can you? Oh, I don't know. So so here's the deal with the Pi. You actually can have a Pi, but something I wasn't planning on getting into tonight. I guess we could, but one of the first things we're going to do in the next session is kind of go through a soldering lesson because you got to put the headers on the Pi. And I mean, you can mount up the Pi now, but you're going to have to take it back off to solder up the headers. How good are you at it? Are you gonna pass the Jeff Gunn School of Soldering Competency? All right, that's pretty good. No, I totally made that up. Yeah, I can. Let me grab the Pis. Okay, so guys, a couple of things about the Pis. My pluralization got really weird there. Please treat these gently, because it's a $10 thing. It's not a huge amount of money, but when there's when there's 10 people in the class, it adds up. Okay, the other thing is that the holes for mounting the Pi are not quite large enough. So these are all M3 hardware. They're 3mm bolts. And the mounting holes in the Pi are slightly smaller than that. So, well, no, I have a drill with a drill bit. You can just widen it a little bit. But with the drill bit, like through the fiberglass circuit board, like that, that powdered fiberglass is really bad for your lungs. So when you're drilling it out, be careful and just make sure not to breathe it, because it's really bad for you.
How do you want us to put the...
Drinking it is probably not as bad for you.
There's a set screw. There's a set screw. Oh, there is?
There's also a nut trap. Did you guys figure that out?
Yep.
Cool. I was particularly proud of that.
That's a...
Where's the specific screw?
No, you can just use any screw.
Yeah, it doesn't matter. It's just the nut gives you something. It's like if you screwed it directly into the plastic, you'd just like strip it right out.
There's no...
But the set screw lets you snug it up. Okay.
Seems a little tight.
So have a Pi. Let me get a couple more.
What's the major difference between, like...
Yeah, it speeds up when it gets past the lower layers.
And, like, the Raspberry Pi, like, normal iteration?
So the
Sign-on is smaller.
Basically just making the hole.
it would work better if you used the tip of the pliers to press down on the nut.
You shouldn't hammering it, isn't it?
Well, that is not the most effective hammer. I'll say that.
Yeah.
Did I?
I have one.
Okay. What were you saying?
Like, what's the main, like, computational difference? It will enter.
So as you kind of move up through the generations or versions of the Pi, they have more cores or a faster clock speed. And basically the price is roughly proportional to how fast or how powerful it is. So this is the lowest end. This is basically a super miniaturized version of the original Pi, which was the size of a mint tin.
So you called it the Pi-tato.
They. It's really good for $10. Come on, cut it some slack. Anyway, so I know, I hear you.
So close, Jack.
So, but like this is like maybe a fifth as powerful as the Pi 4 or something like that.
Because I think I have, like, the Pi BC or whatever iteration that was.
Okay, so it's probably
Third of-
Pi
second or
like a
third.
Pi 2 Model B or like a Pi
Pi
3
2.
Model
It's Pi 2.
B
Can I-
plus or
can I just
something.
borrow that?
You can probably find something online where somebody does like a rough benchmark comparing them. I wouldn't be able to quote specs to you, but yeah, basically how powerful it is about proportional to how expensive it is.
Can I ask you a question? I'm seeing you go. Are you able to fit the little nut in the slot?
Yeah, you just need to like kind of orient it.
Which way?
So,
All right.
Won't be the first time or won't be the last time that happens.
All of that so quickly.
Is this your bin here?
Yes.
Okay, there's your Pi. Here, have the Pi. Sure. No. No, I do not. I think I stepped on another nut over there. Yeah. I think I found it for you.
It bounced right off.
It's like when you walk around barefoot after you get rid of the Christmas tree to make sure you got all the pine needles off the floor.
Have to cut this little slot out, or you just force that bugger in there?
You just need to make sure that the nut orientation is correct. So basically, the slot is the width of
Two
two
flat sides.
two opposing
We don't
flats.
want to be at
Right.
an
So if you're
angle.
kitty corner, it's not going to fit in there, right?
It ain't gonna happen.
Yep. So it's a little tricky, but you'll get it. I believe in you.
It turns out I have excellent vision without the glasses. Right?
Isn't that ironic?
Another thing.
So if you grab a pair of needleless pliers, it should go in. If you need help, though, let me know. I'll give you a hand. Oh, I was going to get that drill. I'm going to borrow one of these. Guys. Anybody see what I did with that dead Raspberry Pi? It was in a little.
It said dead.
Yeah, it was the one that was clearly labeled dead. I put it somewhere. Oh, it's over here. Right.
So what do we need to solve? The headers onto the.
Yeah.
Are we allowed to solve it today? Is that okay?
Yeah, it's okay. If you want to set up the soldering iron, what I would probably do is put it right up here, and there's an outlet kind of down in there. I might actually get you some duct tape. The stand is a little lightweight, and I don't want it to go flying.
Is this supposed to fit in there?
I don't like that. Sorry, bud. Walked right into you.
This supposed to fit in there.
Yes, but the slot is only big enough for, let me show you, for it to fit in. Like, it's bigger across the points, and it's shorter across the flats. So you want the flats facing out, like, roughly like that. And you can press it in the rest of the way with, like, a pair of needle nose pliers or something. Oh, I just 3D printed it. Yeah, totally. Come on, you're like a pro 3D modeler now.
Jack, you're in a room with 2 3D printers in it. Make your own.
I'll get you some headers in a sec. I just want to make sure this is the right size.
Yeah, I know. That's fine.
No, that is not quite big enough. Hey, Jack, do me a favor. Take a piece of duct tape and just like put it across here just to keep it from walking off the table. One of these days I'll get some soldering iron holders that are a little heavier and not so prone to falling on the floor.
I got a new soldering iron and I got a new black solder. I have an old one.
Neato.
I needed like it's a. For leaded solder, and I'm using unleaded, so it doesn't melt the tip after like a month of using it.
That's a bummer. I really like that iron. I got that from Adafruit. It was like 25 bucks.
Yeah, it's the exact same one, except I need a new tip.
Yep.
Because right now I'm just using the Dremel every like once in a while and sharpening it.
Yeah. Yeah, but then you don't have a coating anymore, and so it corrodes super quick. Yeah. Okay, so guys, if you want to mount up your Pi, first of all, if you don't want to, you don't have to put screws in every corner. Like you can, but it's a little overkill. So what you want to do is just gently drill it out, right? Don't be too aggressive because you don't want to crack the board. But if you use this bit, then it'll widen the hole just enough you can get a bolt through it.
Yes.
All
Where
right.
do you mount the Pi on it? It's in the middle.
You can copy this one. Basically, on the design.
I'm too lazy to fix this. Like right here, right?
Yeah, that's fine. It's just don't torque the screw down too tight because the standoffs are to give you clearance because of the pin headers on the
I
underside.
feel like if I just mount these, I could just. No.
Build it upside down. Why not?
Hell yeah.
Totally do it.
Jordan, we're in the same boat.
Yeah.
Nice. You're already making it your own.
It's
You
a
said
low
don't. Do
pro.
you inhale that?
It's a
Yes. Yeah. Yeah. So guys, for those of you that didn't hear, and if you don't get to mounting the Pi tonight, there'll be plenty of time for us to solder up the headers and stuff next week. But if you do decide to drill it out, hey guys, just keep it down a little bit for a sec. If you do decide to drill it out, you're going to create some dust from the fiberglass PCB. It's really bad for your lungs. Don't breathe it while you're drilling it out. Falls out of the air quickly, but. You looking for the headers? Sorry.
I just noticed you have very fast.
I got You're looking for those.
How many?
Probably that many, actually. Like, it's 40 pins total, and so that's probably 40 in a row.
Cut it in the wrong spot.
There should be some 60/40 solder in the drawer here somewhere. Unless it walked away. Might be in the other drawer. Well, you can still solder them in. It'll hold it in place. Somewhere there is solder. 93 through 97. And then I worked there for a couple of years. As long as you get a nut in the hub of the wheel, the length of the screw doesn't actually matter.
Well, I'm looking at it, is it going far enough that it needs screws to hold the motor?
Well, that's a slightly different problem.
Those are standoffs on the bottom and not the top.
Jordan got built racing cars.
What am I supposed to grab out of here?
Are the headers on? Then you don't even.
I don't know where else.
Well, I mean, there's also going to be plenty of time next week to do all the soldering and stuff. So,
I think I'm just gonna solder next week. I'm too lazy to. How much
well,
do we have?
like 8 minutes. So, you know.
Definitely next week.
I'll race you. I said I'll race you.
Roland, you want the long part sticking out so the things on.
I kind of ruined this wheel.
Probably not.
I screwed it in and like
You cracked?
cracked.
Would you like hand the three?
Cracked and started bulging out.
Fixed it.
I have one too. It's so nice.
I'll just print another one and replace it in the kit. It's like a, you know, maybe an hour-long print. Not a big deal. So as you guys are putting these robot platforms together, are you? Thank you. You guys getting any ideas for how you might want to mod them, or what you might want to build out of them, or what you might want to do differently? Anybody having any ideas? I think that is a fantastic idea, and that just sort of presented itself.
Yeah.
So you should absolutely do that. If you have some time in the next week, there's definitely like prior art you can look at, like stair climbing robots. It'd be interesting to take a look at what other people have done for designs, and not that you should. I mean, you certainly could copy them, but I bet you could come up with your own version of it that was still unique. Can anybody think of some way other than a couple of drive wheels like we've got on this robot that you can make the thing move around? What else you got? Legs, that's a good one. Complicated one though. Oh, like props. Yep.
Quadcopter. Yeah. Autonomous drone.
So that's kind of what this is. So it's independent motors. And I like that because it's really flexible and it's simple to implement. But you could go the other way. You could do more drive wheels. Or you could do a four-wheeled bot, right? So the cool thing about the tank drive, you brought it up, so you probably already know this, but steering gets super simple because you just run them in opposite directions. But there's no reason you couldn't have drive wheels and a separate steering mechanism of some kind, like a wheel that pivots, or two wheels that pivot, like a car. Yeah, totally. Or what are those wheels that move in multiple directions? There's like they look like a tire. What?
Omni wheel.
Yeah, Omni wheels.
Right, and then they can like shift and they can go
Yeah.
sideways.
So I haven't worked with any professionally produced ones, but I bet you that's 3D modelable, because you basically need a regular wheel design, and around the perimeter you have like bearings that rotate in the other direction, right? So they give you traction in either direction. That would be a challenging but interesting model to make.
Does anyone have a normal? Yeah.
Yeah.
Sharks make a cross.
You want a Sharpie or a pen? Okay. Somewhere. Yes.
Whoa! What is that?
That? The parts on top or the thing underneath? Oh, this was the top to a Halloween costume. Like I had a staff that I was carrying. Fusion. It wasn't like to go on me. It was to go on the top of my staff. A different iteration of it, yes. Yep. I had to go through I don't have it with me, but I have pictures I can show you. Hey guys, also, we got about 5 minutes left, so just leave yourself a minute to pack your stuff up. But we've got a couple of rolls of masking tape. Can you stick a piece of tape on the top of your bin and write your name so we can keep everybody's stuff, organized? So just grab one of these pieces of masking tape up here. I've got another Sharpie here as well. So pass them around, please.
I started looking at it. And
Cool.
This is the side thing, and this is the main thing.
Okay. So it's like one a part of the other? Is that? Or-
No, but this works harmoniously with this.
Okay, cool. Interesting models. It'd be really cool to work for a game company and actually have your job be creating the models that go into the video game. That'd be amazing.
Oh, darn it. I need interactable.
What's that? There's a Sharpie. It's red over there. I put too much juice through it. I just cooked it. Yeah. So guys, I would love to see you all on the Discord during the week. Let's kick around some ideas. I don't know if you guys heard what we were talking about over there, but we were talking about different drive mechanisms, or maybe doing a 3D model of an Omni wheel. You know what those are? I don't know if anybody's done that already, but a shareable model of an Omni wheel that was 3D printable would be pretty awesome. Something else that I'm interested in exploring, I don't know if I'm going to have time to build one alongside you guys. If I can, though, I will. It'd be really neat to build a balancing robot. Have you guys seen the two-wheeled balancing robots? They stand upright on two wheels, and they use like a gyro and accelerometer to maintain their balance. Have you ever seen that? All right, I'll find one as an example, and I'll put it in the Discord. Yes, and so traditionally you would use an algorithm called a PID algorithm to do the balancing, but I bet you we could get it to work with machine learning instead. That would be pretty neat. So. Yeah. Yeah, that's crazy. So anyway, yeah, guys, let's talk about ideas during the week on the Discord, and then when we get back into it next week, we'll start into some stuff with electronics. I didn't mention this before, but kind of my vision for how the class is going to flow is we're going to build up these robot parts so that we have kind of a base to work from. And that's going to probably take us 3 classes. Like we started building them, we'll do electronics next time. We'll do a little bit with code in the 3rd class. And then for the last 3 classes in the series, we'll try to diverge a little bit. You guys will try to build out from those designs and do your own thing. So we're going to kind of go a couple times around the circuit. Between mechanics, electronics, and code. So, all right, guys, great job tonight. Hope you had fun. I had fun. This is a fun group. What's that? Yeah. Yeah.
It's very similar to the OpenAI Gym cart pool.
Yes. Same idea. Yes. So it'd be like a physical manifestation of that.
Use cart pole to train the robot.
So that's a fantastic idea, and one that Michael and I have done some stuff with that before. I would like to explore that further, where you train the algorithm in software and then move it over to a physical robot to do the thing. That's sort of like what we were talking about before with exploring and then exploiting, right? That's a really neat idea, and I think it's one of the most interesting parts of this sort of crossing over between software, AI, and hardware implementation. So yeah, really cool idea. Yeah, back on the shelves in there, if you got your name on it.
So why LoisLab?
Oh, so you haven't met Michael yet. I hope you get to meet him soon. He's a really interesting guy and a very good programmer, very good teacher too. His mom's name was Lois. She was a teacher her whole life, like her whole career, and so we named the lab after her.
Oh, that's nice.
Yeah.
Who was Lois?
Michael's mom.
Oh.
Yeah. She was a teacher in Springfield, Mass.
Oh, okay.
her whole life. And she passed away a few years ago, only a little bit before I met Michael, so I never knew her, but she made a big impact on a lot of students. So,
Cool.
yeah.
Well, you originally were doing
Javon.
Javon.
So that was just sort of a nod to John
Right.
von Neumann.
Right.
But we sounded a little bit more welcoming, and we kind of, when we built out the classroom, we kind of wanted to do that little tribute. Yeah.
That's cool.
So yeah, I think it fit. So
Well, thank you.
yeah, absolutely.
So are you just dealing, like, I mean, working with high schoolers now?
So high school students and teachers. Yeah. The yeah, and because like we don't want to be a bottleneck. Like we create course materials and we do experiments and things that we want to share and put out there for people to use. Take our materials back and use them, and that sort of expands it and gets it out in front of more people. Everything we do is free. Classes, they're free, the materials are free, so the more people we can get it in front of, the better. So that's the idea.
It was cool. They shared a whole machine learning, the Colab, and you showed me the Colab.
You did us a favor, because you were like our beta testers. All right, thank you very much. I'll see you next week.
Noah.
Yeah, Noah was great. He had a student who was ahead of the other students in class, and so he took the materials that Michael and I have been working on and did it independently.
I just met them sort of mid-class. I'm like, oh, we got this machine learning thing, and I just said, and this kid was sort of way ahead and said, here, play with this.
Yeah.
And he did it.
Yeah.
I would pay for
Which I
like
do.
any more advanced machine learning
this was-
machine learning class.
This was,
Yeah, I think because it's just Michael and me,
yes.
we're pretty focused,
Yes, you were.
and like maybe we would have more offerings someday. I mean, I know that there would be interest just because see you well,
Hey, well, see you tomorrow.
because it's such a hot topic and like there isn't a lot of education that is starting at a really approachable level and going right up. I mean, like that was actually one of the big motivations for Michael to start learning about machine learning and then figuring out how to teach it at a high school level. Because if you're a student, like say you're somebody coming out of your program and they're going on to a university program and they want to study artificial intelligence, they don't get to the actual artificial intelligence until junior year, right? They have like 2 years of math prereqs and all of that kind of stuff.
Right.
And Michael was looking at the material and said, if you break it down to concepts and you use simple examples, like the way that was learning was using something called Q-learning, which is mathematically very straightforward. Students can learn the concepts and write their own algorithms, and there's no black boxes. It's not like taking somebody's deep learning algorithm and somebody's pre-made environment and sticking them together and just doing the plumbing. It's like you're really peeling back the onion and understanding it at a fundamental level. And so I have no doubt that, if we wanted to go and teach people in the industry, machine learning at that level, that like it would be popular. But, right now, the thing, I didn't bring it up tonight. It's a conversation to have with the students after they've had a couple of class experiences. But our sort of secondary motivation is to give kids opportunities and teach them the value of independent work, right? Because this class isn't about making a robot. This class is about learning the concepts so they can design and build their own robots. And the hope is that if even just some small percentage of the students are so interested by that pursuit, they want to keep doing it on their own. And they learn how to find problems that they want to solve and then do the work and then tell people about it. Like that set of skills is what's going to get them really far in life. That body of work and the ability to talk about the work that they've done, that's job interview material, that's college application material, so that's kind of the opportunities that we're trying to create. So
It's so young,
Yeah.
in your head, I think it just makes it easier
Yeah.
to grow
Right.
on that.
Yeah. So the lab, this is something else I didn't bring up with the students yet, but this lab, we want this to be a resource to them. So Michael and I are both here basically in the afternoons, right? So we teach classes in the evenings, but if students want to come in after school and work in the space is here for them. And once we finish the classes, if they want to continue working here because maybe they don't have a space or they want access to us to mentor them on their independent projects, we're here for them. So we're trying to create a community around the space. Hi.
Hey, they're coming.
Oh, yeah.
Looks hard, I think it is.
Okay.
So what should we?
I will take a picture of it and I will talk to the landlord to get it removed. Whose car was it?
Rollins?
Okay. Yep. Don't worry about it, but let me just take a picture.
I got one of those.
Yeah, it's not. It happens from time to time. It's like
No one else got tickets.
Yeah, no.
Like, what was special about the one spot?
so. This is totally. This is not based in any science, but I found that the further into the
I wasn't in the lot.
no. What I'm saying, the further into the lot you are, the less likely you are to get ticketed.
Oh, I see. Okay.
If you park against like 3S, like Barrio, for some reason they take it more often over there.
Okay.
But don't worry about it. I will email them tomorrow. You're not going to get in trouble or anything like that. Hang on to it though, just in case. And I will email you when I have confirmation that it's all set.
You know, a thought I'm having right now is that at some point, if you guys, you know, if you want to work on filling a class,
Yeah.
you could pull together a task thing. It's we don't need to open block a task where I could task in a group of kids.